Hi, in this video, I'm going to be showing you that a 30, 60, 90 degree triangle has some relationship between its side lengths. The shortest side we'll call x, and that's across from the 30-degree angle. You can remember that because it's the smallest angle and it relates to the smallest side. The second largest side is going to be across from the 60-degree angle, and that side's measurement is whatever the smallest side is, so x, times the square root of 3. And the longest side is going to be equal to 2 times whatever that smallest side is. So we'll call it 2x. Now, if this is true, we can use the Pythagorean theorem. A squared plus b squared is equal to c squared, where a and b are the two shorter sides and c is the longest side. So I'll use the Pythagorean theorem. X squared, that's my smallest side squared, plus b squared, so this entire quantity, x times the square root of 3, is being squared, is equal to the largest side squared. Well, that's 2x, and the entire thing is squared. So now I'm going to have to simplify a little bit. Remembering the properties of exponents, this essentially has an exponent of 1, this essentially has an exponent of 1. So we go ahead and distribute, and we multiply each exponent by 2. Likewise here, this 2 has an exponent of 1, this x has an exponent of 1. So we multiply each by 2. In simplifying, we are going to end up with x squared plus x squared times, now this is the square root of 3 squared, and those two are inverses. So the square of a square root is just the value under the radical. And then this will be equal to 2 squared, which is 4, times x squared. Well, now I can simplify. I have x squared plus 3x squared is equal to 4x squared. Combine these, we have 4x squared is equal to 4x squared. We can take the square root of both sides if we want. We can add a million to both sides if we want, but we know that this is true. It's equal on both sides. We'll end up with 2x is equal to 2x. If we really want to, we can divide both sides by 2, and no matter what x is, we have a true statement. So we know this is correct. Let's go ahead and take a look at a concrete example. Let's say if x was equal to, let's say, 5. Well, we'll be looking at some 30, 60, 90 triangle where this side length is 5, this side length is 5 times the square root of 3, and this side length is 10. Let's go ahead and check it out and see if that will work. I'm going to leave it in radical form, so that way I don't have to worry about any decimals. I can do all this mentally. I take 5 squared, the smallest side squared, plus 5 times the square root of 3 squared is equal to 10 squared. So 25 plus, if I factor or multiply this in, distribute it essentially to the exponents, I'll have plus 25 times 3 is equal to 100. Well, this gives me 75 plus 25. That's 100 equals 100. If we take the square root, we'll find that 10 equals 10. That is correct. And so what we can do now, knowing that these relationships exist with 30, 60, 90 and 45, 45, 90 triangles, we can identify missing sides if we know angles and side lengths, but maybe don't know some of the other sides or don't know all of the angles. So it's kind of like little puzzles that we can solve, and there's a IXL skill directly related to this. Thank you for watching.